Good afternoon and good morning, everyone. Welcome to our first virtual road trip of 2021. I'm Molly Soltis with Asphalt Testing Solutions and Engineering, and it's my pleasure to welcome you on board today as we travel to the west to Reno, Nevada. We're joined by two industry experts who will discuss the importance of material management and handling. Before I introduce them, let's go over a few housekeeping items for those who might be new to Zoom. In the bottom left-hand corner of your screen, you'll find the audio settings. Since you are a webinar attendee, you will be in listen-only mode. Later in the webinar, if you would like to join the conversation, you can use the raise hand icon. Time permitting, we'll unmute you so you can address our presenters. If you have a question, but you prefer to stay muted, you can use the Q&A window. Open this window and type in your question. Today's speakers are Tim Webster. He's our Performance Lab Manager here at ATS. He has over 15 years of experience in the industry, and 13 of those are with the Florida Department of Transportation in various roles, including Bituminous Lab Manager. Dr. Adam Hand is an Associate Professor at the University of Nevada, Reno. He has over 20 years experience in the industry, 16 of those with Granite Construction Company in various roles, his most recent being the Vice President of Quality Management. He is a registered professional engineer in several states and has published over 100 papers and technical reports. So I think we're about ready to start. Adam, if you'd like to join on, and everybody please fasten your seatbelts and enjoy your trip.
Well, good morning, everyone. Good morning and good afternoon, depending on where you are. I'm going to go ahead and get my screen share going here, and thank you all for being with us today. As Molly said, if you have questions, please do raise your hand. Really, today I'm gonna talk about, again, the topics: materials management and handling. We're gonna sneak a couple other things in along the way, and maybe a few experiences along the way that again, you all could benefit from. And then do the Q&A. So I'm wide open. Again, don't hesitate to raise your hand, and look forward to the interaction. With that, I'm going to minimize something here. Yeah, with that, I'm going to talk really about the topics: materials management and handling, but I'm going to sort of break it down into planning, sampling, managing samples, integrity, traceability, and then the impacts of all of those things on materials and test results, just in a small portion. Joe had done a previous webinar in the ATS series, summarizing the findings from the NCHRP 552 project, and the link to that webinar is right here. And at the end of the presentation, I'll have the references to a couple of documents, including this one, that you may find useful in your jobs. So when we talk about planning, which was the first item on that list, you got to think about the material you're using, why you're sampling it, what's the purpose of getting the sample, where you're going to sample, the size of the sample. Is it a if it's a QC sample and it's a gradation from a belt cut, or is it a stockpile, several bags of stockpile aggregates for mixed design? The process that you're going to use, you want to make sure that your samples are randomly selected and that they're representative of the material that you're ultimately going to test in one form or another, or use to fabricate test specimens. And then once you've got those samples, obviously splitting them, right, getting them into whatever containers you're going into, or if they're from containers into the test specimen sizes, and keeping everything labeled along the way, so that there's some traceability associated with the samples. And then finally, storage and integrity of those samples. And something that's a really good tool is what I call ITPs, or inspection and test plans. And this is an example of one for aggregates. And these are aggregate sizes here, different products. These are tests, and so what this simple table does is it summarizes what's going to be sampled, where it's going to be sampled, when, because you got a frequency in there, and then how. So it's a great tool, right, to summarize all that and make it really clear to communicate what's going to be done in terms of sampling. Okay, this is another example of a tool. It's a very clear written set of instructions on how to obtain cores for some bond strength testing, and it goes through again specific instructions on making sure that the location of where they're taken, the identification of them, making sure that the core rig is perpendicular to the pavement surface and all that good stuff, so that or perpendicular to the bonds, so that you've got good material when they arrive to be tested. And I don't want to go through this. Just the idea is sometimes you have to be, a table like that is really all you need, as opposed to this situation where you need more direction than that. Now, when it comes to the purpose, the purpose of this slide is really to demonstrate different types of samples and how they might be used. So this is obviously a hot plant, and in this example, I've got what I've called process control, quality control, and acceptance samples identified. And acceptance would be what the public agency would be using, or the owner would be using to accept the material. And so let's say in this example, we're looking at the gradation of hot mix asphalt. So the agency or owner might be using something like mix on discharge from the drum. They may be also getting samples from a truck on load out into from the silos on unload out into trucks, for example, or maybe even out at the project. But the point is, the sampling location is different, right? And the purpose is different. Now, all of these are to control gradation, but again, we've got different sampling locations and purposes. That's the acceptance example. Now, by contractor might be required to perform quality control, and the quality control might be done on, for example, belt cuts. So aggregate samples from the collector belt going into the drum, and of course, if you're feeding wraps separately, you got to get samples from there too, and test those materials separately, and then combine them. And then, of course, a contractor might be doing, actually the wise contractor is doing stockpile sampling and testing, not only as they're producing, but also as they're building their stockpiles, so they get the sort of the average of the piles to be used for mix design purposes. But then during production, as they're loading out of the stockpiles, to make sure that they're going to have passing quality control tests. So those are different purposes, right? And ultimately, though, they're all measurements of gradation, and there may be different methods used. So, like on the mix samples, you've got to run an extraction on it and get the asphalt binder off of it, whether it be with an ignition furnace or with a solvent extraction, so that you can get to the aggregates, where the other two materials, the QC and process control samples, you've got the aggregates directly. So, and you might also, for example, on an acceptance and quality control test, it's really important that you follow all the details of the test methods that are specified, where a producer may, on their stockpile samples, they may be doing I don't know, something to accelerate the drying process of the aggregate or something like that, to get quicker answers, especially when you start up at the beginning of the day. Now, the Code of Federal Regulations, CFR 23B, states that if on a project the contractor is performing quality control and the agency or their representative is performing acceptance tests, that the samples that are used by the contractor and the agency or the DOT have to be independent. And this slide is an effort to illustrate that. So this would be a pavement. So up in the top here, we've got a pavement, and 5 cores have been taken out. So 5 random locations were identified, 5 cores were taken. Now those cores include 4 sources of variability: materials and process. I usually call that materials and construction, sampling, and testing variability. Now, if you use split samples, which is illustrated on the bottom part of the slide, same idea there. You've got a pavement, and in this case, 4 samples are taken, and the one on the far right is split into 2, right? And so in this case, cores are not a really good example of this because you don't really split cores. But if, let's say those were loose mix samples, then what happens is that split sample only really integrates testing variability. So it's not an independent sample, and split samples can be used depending on the situation, but as long as it's not for verification of quality assurance tests by the public agency with basically with PWL type specifications. It's really important to know, make sure we're getting the right kind of samples. I don't know how many times I went to pre-construction meetings and there'd be an agreement between the RE and the contractor to go ahead and have the contractor pull samples and split them for the agency and for the contractor, when they were really supposed to be being pulled independently. So the other thing is, again, making sure we've got representative samples. If you do your random number generation and you get your sampling locations, if there's some issue there when you go to sample, you need to recognize that and maybe do something different. Get with the RE and make sure everybody's on the same page, but make sure that you don't intentionally get a sample that's not representative. And of course, you need to be thinking about your purpose and use. And I've got some examples listed here. For example, mixed design, process control, quality control, acceptance, and research. And the questions posed: what might be different based on use? And so, for example, I think I used the mixed design example already, right? So for mixed design, you're going to get a pretty significant sample, right? A pretty large sample. You're going to get several bags or buckets of material. Where with a process controller, let's use QC since I used the cold feed collector earlier, you're going to get a much smaller sample, right? You want them both to be representative and randomly taken. Now, when you get to something like research, you may want to get a very, very large sample. So you don't want to start a research project that might be influenced by aggregate variability and aggregate properties, and sample stockpiles at a contractor's or producer's yard, 3 times during the project, 3 months apart, because there will be some variability there. So you want to minimize the variability in that case because of the situation that you're in. So you have to think about those things again when your purpose and your use when you're setting up your sampling plan. Of course, anytime we sample, we want to make sure that we're using the appropriate containers for our samples, whether it's asphalt binder, aggregates, or hot mix. And those containers need to be obviously clean when you go to use them the first time, and then they need to be properly labeled, right? And they need to be delivered to wherever they're supposed to go. And this is I'm going to talk about traceability. The labeling piece is really important, and depending on the situation, there may need to be chain of custody forms and so forth used, but I'll talk about that in a minute. Now, sampling is there's safety, or can be safety issues with sampling. It's just a reality, right? And depending on whether you're on the job or at the maybe you're at a quarry where a plant is or something, then you have either OSHA or MSHA as the bodies that would be paying attention to the practices that are being used, and they're there for a good reason, and that's to keep everybody safe. So I'm just going to go through a couple of examples here, and I'll start with the components, right? So this is a gentleman. He's sampling asphalt binder. You can see in his right hand, he's got a valve open and he's holding a little quart can, and he's filling up the can. And the purpose of this slide is to illustrate a not really a very good sample. Granted, he's got a face shield on and gloves, but if there's splatter from that process, a lot of times, right, the sampling, the pipe will have a slug of material that gets cold at the end of it. When that comes out and goes into the can, that can splatter all over the person trying to fill that can. So the purpose here is to start with, when it comes to safety, when you're sampling, you have to have the proper PPE, the right equipment. And the fastest method isn't always the safest. And you really need to think about that, because the end of the day, this is really about the health and safety of the people doing the sampling, right? So you want to make sure that everybody's as safe as possible. So that's a not so great example. Here's a couple of examples that are much better, right? So you got your sample container inside this box. The person sampling's got the proper PPE on, and as long as they don't open the valve with that door open, they don't really have the opportunity to get burned anyway. So again, this is a Maxim device. This is a homemade one that was built before these were available. This is a vertical face and a wrap stockpile. This is a person sampling on, that's almost 150-ton stockpile of a base course. The person's climbing on it, so those are things we don't want to do, right? We don't want anybody in there sampling that. They could get buried, and we don't want a person getting buried climbing on a pile either, right? So we've got loaders, right? At our plants, we've always got loaders, and a loader operator can go blend up the face of a pile and make a smaller pile to sample from, and again, in a much safer manner. This is truck sampling. In the bottom right, we've got a gentleman standing in the truck, leaning up against the tailgate. In the middle, one leg on the sampling rack, one leg in the truck. And then in the top left, we've got a pretty good reach to get from where those ladies are up on that sampling rack down into that bed of that truck to get samples. So that's really a backbreaker. So those are three, practices that aren't really all that safe. There are better ways of doing this if you want to get a truck sample. This is an example where there's a different type of rack. Again, the person isn't getting in the truck. I'm aware of drivers taking off with folks standing in the back of trucks, like in this scenario here, where the person's up against they've got their leg up against the tailgate, and the driver actually takes off, and the person fell out of the back. Unfortunately, they weren't killed, but it can be really, really dangerous. And this is probably one of my pet peeves also, and that is coring safely is really important, because if you use these little core rigs like this, and the operator has to stand on them to keep them in place, right? If they bind up, right? If that core barrel binds up and that drill keeps going, right? You're going to try to spin, right? And the operator can get twisted up in that, and I had somebody that worked for me have that happen to him, and ended up with several broken bones, and actually ended up leaving the industry. So again, there's better ways to sample, safer ways to get cores than that. And here's just a couple of examples. So I'll get off my horse on safe sampling practices. And again, the idea is about keeping everybody safe. So when it comes to aggregate sampling, we're always going to have some segregation, right? If you've ever spent any time at a rock plant, you've got on your conveyors, you get segregation, right? The fine material goes to the bottom of the belt, coarse material rides up on top. And over here on the right, you can see an example of when it comes off the head pulley, it discharges from the conveyor, you have a coarse and a fine side of your pile. So you want to make sure you're getting representative samples, right? So that's important to consider. These are a couple of tech. This is a belt sweeper. It's an automated sampling device. Well, it's actually the belt sweeper's right there, and it discharges down this tube into a bucket. And this is actually a stopping of the belt. The belt sweeper, you can sample on the fly. Again, it's very safe, but you need to recognize you don't get every bit of the material off the belt. So you need to stop the belt sometimes and get a correlation between belt swept samples and actual samples where you clean your belt off, so you can get it's basically a 200s correction. And these are a couple of examples of on the top left, we've got a fine aggregate stockpile sampling, and some states still require that you use the tube method for fine aggregate sampling. Others allow you to sample like you would coarse aggregates. The bottom left, we've got again, a loader operator has blended the face of a pile and created a platform from which the technician can sample. And on the bottom right, we've got our quartering exercise, right? So when we sample, we quarter, we take the sample from combining opposite quarters, consistent with whatever our public agencies, our owners requirements are. And then of course, up in the top right there, we've got some bagged up aggregate samples. This is a remote truck sampling device. These are, I think they're really good tools from a safety perspective. They keep everybody out of the truck. They're quite expensive, and because of that, I think there are a few of them out there than there could be or should be. But it is a good technique. And when we're sampling loose hot mix, again, it may be on discharge from the drum also. But not only do we have truck samples, but we may be taking windrow samples. We may be sampling from behind the paver, like on the upper right. Regardless of which technique we're using, again, it's really important that the procedures that are specified are closely followed. Lots of opinions on which is the best type of sample. A lot of agencies say we want to sample behind the paver because we want to sample the final product. Sometimes, I've seen samples taken from hoppers of pavers. I don't really personally don't like that from a safety perspective. But there again, location matters. The part of the point here is we've got different locations, and locations matter. Finally, this is sampling some cores, and the idea of this is, remember that if your sampling has to be witnessed, that you communicate so that the witnessing takes place, so you don't have to go back and resample. Of course, anytime you're sampling, it's really important to keep records, and they're depending on your situation and the type of sample you're taking, the record requirements might be different, and the intent here isn't to go through all the different types, but just to recognize that you need to be recording what is done, where it's done, when it's done, who did it, and how it's done. And there are some extremes here. For example, headlight is a software that you can take pictures and your coordinates are captured and all that good stuff, and it can be tied to products in the software. A lot of folks, you'll see them out there with the clipboard, right? And then you'll see things like, cell phones being used. In the upper left corner, again, we've got somebody witnessing. That gentleman is witnessing the map that's on the lower right corner. This is unfortunately, this is a location where mix was sampled on that's a 3-inch lift, a 3/4 inch mix. It's 14 feet wide, and that mat's pretty beat up. That's not going to be a great performance, or from a performance perspective, that's not going to be really great. So if you do sample from the mat, there are techniques again to minimize some of the issues that you see in this mat here with the segregation. I brought up splitting earlier. Regardless of whether it's binder or aggregate or hot mix, when you're splitting your materials, again, the goal is to get representative samples that are of the appropriate size. There are different techniques that can be used. Riffle splitters for aggregates are very common. They're used quite a bit for hot mix also. And then spade splitting, like on the bottom left, is fairly common also. So again, it goes back to, and we've got a quartermaster on the right. So it goes back to what the agency requires, right? And being consistent. So you don't want to be, have one lab using a riffle splitter and the other one using the quartermaster, right? You want to be consistent, especially if results are going to be compared across those labs. I'm not going to get into much detail beyond that in terms of splitting. The one thing that I'll sort of harp on is that whenever you're splitting, make sure that you always start with the entire sample. One of the best examples I can give of that is when we showed the sample containers as 55-gallon drums. So on large projects, it's not uncommon to get 55-gallon drums of aggregates, for example. You line them up and have the loader operator blend the pile and then pour them into the drums. But if you go in there and take a shovel or a scoop and dig, a quarter of that material in that barrel out, and then split that and then go use that to fabricate samples, you're fooling yourself, because as it was transported, fines migrated to the bottom of that 55-gallon drum. And so you need to dump the whole drum out and quarter that and again split until you get to the appropriate sample sizes. So a bucket is really no different. It's just 5 gallons rather than 55 gallons. Okay. Now I brought up the sampling location, and I'm going to just use a quick example here to illustrate the importance of it. We saw in the slide where we're looking at independent versus split samples that there are multiple components of variability. So we've got the total variability is made up of variability associated with sampling, associated with the test method that's being used, and then I use material and construction. Some folks will use material and process. But at any rate, what I want to illustrate is the impact of different sampling locations here. And sampling variability, this goes back to some work done around the ASHO road test, but it was determined that 10 to 30% of the total variability in a test result will be due to sampling variability. Okay, now this slide shows these are sieve sizes, and this is the standard deviation or the variability in the measurement of the gradation. Again, individual sieve sizes for 45 or 46 samples taken from 3 different locations. The diamonds represent cold feed samples. So we go back to our hot plant example to slide 2 or 3. So they were pulled off of a cold feed collector belt, or the conveyor going up to the drum. And there were 45 samples. And then the loose HMA, that was loose mix, which is the squares. That's loose mix sampled from trucks. Okay, so those are truck samples. Ignition, asphalt contents were determined, and then the gradations were measured. And then the pyramid, or the pyramids are cores sampled from the pavement after completion of compaction. And I have to note that on this project, this is a 3/4 inch mix, and there was a material transfer vehicle used. So if you think about it from a segregation perspective, the remixing that you get with your MTV, as long as you don't create segregation with your paper, leads to lower variability. And the point here is, so if you take the number 4 sieve, which is the extreme example here, the standard deviation on 45 measurements of coal feeds on the number 4 sieve was 5. That's huge. That's a really, really big number. Where, based on the cores, it was all the way down at 2. And for those of you that work under PWL specifications, the importance of variability. So it's really important that everybody is sampling from the same location for the quality, the assurance, and the quality control test, so that you don't have this issue of sample location negatively impacting not only the comparison between the results, but also if the specification was developed based on, let's just say, loose mix variability associated with loose mix taken from truck samples, then you go ahead and use cold feeds. Well, your specification, you're going to fight your specification because your specification is tighter than it should be for that cold feed location. Really, really important. So how do we minimize sampling and testing variability? Well, there's the obvious things, right? Having well-trained technicians, and there are many technician qualification programs out there, whether they're regional or state. So I was talking about the importance of sampling location, and then techniques for minimizing variability associated with sampling and testing. So again, technician certification, lab accreditation, and then standardizing options within methods. Of course, checking in every once in a while with proficiency samples is always good. And something that the FAA does is they require that you essentially require that the testing be done on projects sort of on site, right? And that both parties be testing in the same lab. There's some good in that they have to set the labs up and do some testing before you go to work. So if there's going to be any issues, they get resolved before you get a project going. So that's really important. Labeling is important, right? Here's some good examples of laboratory prepared samples, right? On the top left, you have one that's very well labeled. Middle one that's pretty badly labeled, right? She's got a number 3 on it. If you got 100 samples in the lab, what does number 3 mean? The bottom right is, if we went from good to bad to ugly, we can't even see the writing on the specimen. Now, this is an example from MaineDOT. Maine, because of the desire to have, the integrity of their samples maintained for their quality assurance samples, they require that basically you use security tape, or that's with loose mix or hot mix, loose hot mix in the upper left. And then in the bottom right, that's a crate that you put cords in. And there's a tamper-proof seal that's put on that. So again, depending on your situation, your agency, you may have to do some of these things, and it's just important that they get done properly, so that when you're not going back trying to get new samples after the fact. Okay. Now, one of the things that's really important also when it comes to sampling and it's really storage. It's how you handle the storage of the samples, and it's particularly important with hot mix. Okay. Obviously emulsions also, I haven't really talked about emulsions, but emulsions just because they have such a short shelf life. But one of the things that I've seen many times be an issue is that when you sample hot mix, and you there are 2 parties testing it, and what happens is one party, for example, might let's say you take truck samples. One party might take that truck sample and immediately go do their volumetrics. While it's hot, they don't have to reheat it or anything. The lab's right there. They go in and they, split out a rice and split a couple gyratory samples and compact them, and they're done. Where the other sample might go to a lab that's, I don't know, a 4-hour drive away, or maybe even it might get put on the shelf and sit there till the next day, and it gets reheated. And then the time of reheating is not consistent. And this will lead to differences in volumetrics. And this could be a really big deal. This is probably one of the more common issues that I've seen with this differences in volumetrics among labs using the same materials. And it needs to be standardized. I mean, it's something that needs to be standardized. And the question is posed at the bottom there: does silo time matter, and does reheat time or temperature matter? And I think it's no different whether you're looking at silo time or reheating time. They both matter. The temperature and the time matter. So anytime there are differences, especially if you have aggregates that are more absorptive, you're going to see pretty good differences in your volumetrics, and that can be a challenge for you. You see. Okay, I see a question in the chat box here, and it is: when I have an uncool sample in box for retesting, how is the procedure for warming to mixed temperature for realize the different control test? I think the question is really around I think that the question is really around what procedure should be used, and that's something that needs to be defined by the agency so that everybody's using the same procedure. It's really important that there's consistency. Now there may be different procedures that are required by different procedures, and that can be okay as long as within a procedure or within an agency, it's always the same. So I can't tell you what the best method is or best procedure is, but what I can do is suggest that you use a common procedure. And if one doesn't exist, then push the agency to get one in place so that, again, everybody's doing the same thing. It's a really big issue. So thank you for the question. Hopefully I answered. If not, please shoot another one at me. Okay. Now, when we prepare, it looks like there's another one there. This procedure is for use in Panama City. Okay, great. So if there's not a standard that's used for the city, then I would encourage you to grab one from somebody else, another agency, share it with the city, and get them to agree to some standard. And you're going to see different standards around the country, but what is really important is that one is picked and is consistently used. And the differences a lot of times will be because in different parts of the country, you may have very absorptive aggregates versus aggregates that aren't very absorptive. And it's even more important, the importance of this is even greater with more absorptive aggregates. Okay, now if we go to our volumetric and performance test specimens, we spend a lot of money preparing them, especially performance test samples. So we want to make sure that the integrity of the materials that we've taken is good when we go to fabricate those. So if we take loose hot mix, put it in boxes, and put it store it in a C train, a storage container in I don't know, in Florida in summertime, for a day versus 3 months, we're going to get differences in the properties that we measure with our test. So the integrity, controlling the temperature and the time, is a really important part of the integrity piece. So, and again, if you're making, there's an AMPT sample up in the upper right corner and a beam fatigue in the lower right, if you're fabricating those samples, you're spending a tremendous amount of time and money to prepare them. So if the integrity of them isn't very good, then it's a wasted money. There's something called thixotropy, which is basically binder essentially stiffening, right? When it's not moved. And so if you prepare specimens, this is a bunch of performance test specimens, right? If you prepare a bunch of specimens and you leave them, even if they're properly prepared, they're properly stored, right? But they're stored for different periods of time, you may get differences in your test results. So you really need to stage your samples so that the amount of time from when they're prepared to the time that they're cut and ready to go to be tested is similar among each sample. So if you're doing a beam fatigue test and it takes a day, right, and you only have one beam fatigue device, you don't want to make 30 beam fatigue specimens and leave them sitting on the bench and probably take like 45 days in between the time that the first one and the last one gets tested. This is really, really important. Okay. This slide is just sort of a summary of things that I've seen over the years that have been challenges with sample prep. And I know Joe did a whole separate webinar on this, but the aggregate batching with lab mix prepared samples, seen lots of differences in volumetrics because of batching procedures where some folks are correcting for 200s, other folks aren't, or maybe some are breaking down on every sieve and recombining, some are maybe breaking down on the +8 and -8, they're leaving together, and again, you really get differences in your fines, which leads to differences in volumetrics. Then of course the aging time and temperature. I already talked about the reheating, right, with the plant mix, lab compacted specimens. And then one of the things with cores that's a fairly common challenge is the cores are sort of skewed because the trailer might be set up, or the core rig might be set up rather than being so that you get cores that have nice straight sides on them. You get cores that are basically taken on a skew. Okay. One of the things that I like to use or see used when it comes to sampling is control charts, because if you collect your samples, you run your test, if you plot the data, okay, whether it's individual properties or combinations of properties, okay, and you plot multiple properties, okay, you can see if you've got what kind of variability you have in your test results. And you can look for sampling and splitting and testing variability as potential sources of variability in your combined results. You also, with control charts, you can do things like plot, or with plots, you can do things like plot the number 4 or 8 sieve versus asphalt content. That will tell you if you've got segregation in your samples. Okay, you can do things like plot your asphalt content versus your GMM. Right, as your asphalt content goes up, is your GMM changing in the right direction? Is it going up or down? Right, you can plot your effective specific gravity. That'll tell you something about your absorption or if your aggregate properties are changing, right? So I like using GSE and effective binder, and the number 4 or number 8 versus asphalt content in particular, okay? And again, the questions posed here, do you use control charts? And if so, is it voluntarily done, or is it because it's required? And then if you do use control charts, you use Schuhart's control chart rules. Okay, he worked for the Ma Bell, the Bell telephone company, and he developed the whole statistical process control using control charts. Basically that we use today. If you go look at Six Sigma and all that good stuff, it all it goes back to Schuhart's work, and there are rules when you can look at trends in your control charts and make decisions on when to make changes in your production based on that. So they're really, really good tools. Here's an example of this is number 4 and number 8 versus asphalt content. And you obviously, right, it makes sense that as the amount of material passed in the 4 or 8 sieve goes up, right, your asphalt content would go up because you have more finer aggregate, you have more surface area. Okay, so again, you can detect segregation with these control charts. I don't want to pass up on the opportunity to remind us all, though, that we go out and we sample and we test and we collect all this information. But if you're sampling, you can be inspecting at the same time. And in this example here, you see the material coming off of that radial stacker there is brown, and the material beneath it's gray. And you don't need to run a test to know that something's changed, right? That's when you go to the production folks and say, time out. The pile's gray, and all of a sudden there's all this brown material being dumped on it. So what do? We stop, and because that doesn't do anybody any good to go ahead and put dirty material on clean material, right? And there's lots of places we can inspect while we're sampling. And I won't go through all of these, the locations in detail, but just, starting with the mine face all the way through the paving operation. We might be looking for different things in those different locations, right? For example, on discharge from the drum, we might be looking at coating, right? Where at the paving spread, we might be looking for segregation. And again, the idea here is if you see something, say something. It's kind of like safety. Quality to me is no different than safety. You hear all the time, if you see something, say something when it comes to safety. Well, the same thing goes for quality. If you have to redo something, it costs twice as much to redo it as it did to do it the first time. So you want to catch things and fix them when you can. I'm going to wrap up with traceability, and this is a pet peeve of mine. And so what is traceability? It's really having the ability to verify that you're giving your customer the product that you said you were going to give them. And the reason that matters, right, is you may be in situations where you have to prove that you delivered the right product. And so I'm going to walk through an example of traceability, and I'm going to use asphalt binder as the example because it involves multiple parties, and it's a single material. It makes it a little bit easier. But when it comes to traceability, with asphalt binder, when you're purchasing a binder, okay, you have a specification, a purchase order, a bill of lading, a certificate of compliance, and a submittal that are all documents that can be used in terms of traceability. When the material is in possession, right, then you've got things like labeling on your containers. You've got chain of custody forms that might be used to transfer custody of samples from one entity to another. You've got witnessing that may go on. Of course, you may have quality control and quality assurance testing inspection. And then if it's at a hot plant, then if you're trying to tie the binder that was used in mix back to a product that's a mix, and you have your plant inventory records, your plant production records, you have your truck tickets, which should tie your mix design back to the mix ID and your plant controls. Your plant controls, you should have the tank that you're feeding from, and then you should have, again, all the stuff on the left relative to the binder that was in the tank. So the purchase order is really the official agreement between the buyer and the seller. It's really important that in your purchase orders you reference a specification, because that's what you're holding your supplier to provide the material to. So it doesn't matter what state you're in, if it's a state or other public agency, just use, or even a private owner, whatever specification they're using, reference that spec in your purchase order. It's just an example of a Section 92 of the California Department of Transportation spec. This is a purchase order, okay? So it identifies, right, the vendor who's supplying the material, who it's going to, and it will have, that purchase order will have a number on it. And in this example, it's a 100 series. Now, this is a bill of lading. A bill of lading is delivered. So when a truck shows up and delivers asphalt at a hot plant, then that truck driver should have a bill of lading with them. And that is provided by the supplier, and it says, it's got the product identified, right? The amount of material that was delivered. And of course, it's got to be signed by the recipient, so somebody at the plant. And you notice I said this, the purchase order on this was a 100 series. So this is that 100, 194 is tying back to the purchase order. Now, you not only have a bill of lading, which is really it's almost like a chain of custody, right? Because you got signature of the recipient as well as the quantity there. But then you get a certificate of compliance typically. Most states have what are called COC programs. And so in this example, the measured properties on the lot of asphalt binder that was produced associated with the delivery for purchase order 100, 194, right, is provided. So those test results are provided in a COC, certificate of compliance. That's, again, something else the driver provides the person at the plant when they deliver the material. And it illustrates their compliance to the requirements. Now, that doesn't mean that you should always take that at face value, right? You may want to do some testing of those materials, and you might be buying aggregates as a hot mix supplier. Buying aggregates would really be no different. So you'd want to verify at some level, do some QC or some QA, depending on whether you're the contractor or the owner. Okay. This is labeling. It's just the idea here is to illustrate. These are labels. This is a binder supplier. They've got all the pertinent information on the material that's sampled. So those would be samples that were taken when discharging the binder from the truck to a tank. Those samples would be taken. And this just shows a close up with more information. Again, different sets of examples. Now this is a tank, horizontal tank at a plant, and these are cans of material. And the question here is, do these appear traceable? And the reality is no, right? I mean, this has been sitting here so long, it's got rust on top of it, right? So even if it did have if somebody did write on there with a paint pen, you don't know what the heck it is. These don't have anything on them. A couple of them have writing on them. A lot of them don't even have writing on them. Those aren't traceable. That's not good practices. The other thing is keeping a log of all your samples. Now, if you're working in an AMRL accredited lab, you know that everything that comes in the door has got to be sampled or got to be logged. It's no different when it comes to process control, quality control, and acceptance. Logging all your samples where you've got a unique ID on the sample that's tied back to, again, your bill of lading, your COC and the individual sample that was taken and put in that can is really, really important. So again, it's just all part of the process of creating credibility in your traceability. This is an example of a chain of custody form. It's just a form that is signed as possession is transferred with a material. So again, somebody delivers a bag of lime. If you're using lime to treat your aggregates at a plant, the recipient of it signs off on it. Okay. Now, sample storage integrity is really important. I talked about putting material in a C train and letting it sit there in the summer. So having the right climatic conditions, right? First of all, having the samples properly in proper containers, properly labeled, so they're traceable, and then inside an environment that protects them from their properties changing as a function of time is really important. And you can see in here, these are box samples of mix. These are cans of asphalt liner, and there's more on the other side of this. Yeah. So with that, I'll get off my traceability horse and remind you that there are a couple of good NCHRP references out there. One is the one that Joe did the webinar on practices for fabricating specimens for performance testing, which is sort of the step after what we just talked about. Another is NCHRP Report 818, and what that does is that has got a synopsis of differences you might see when you go from your laboratory mix design to field production in terms of volumetrics and mixture property tests. It's a good resource as a sort of a ballpark check on differences that you might see there. With that, I'll wrap up with really going back to where we started. When it comes to sampling, we want to make sure that and handling, we want to make sure that we've got a plan. We want to know what our purpose, use type, or whatever is so that we get the best outcome. We want to be safe when we're sampling. We want to keep good records so that we have traceability. When we're preparing specimens, whether it's for QC or performance testing, whatever, we need to think about how we handle those materials influences the outcome of those tests. And because we want to minimize the differences in volumetric and performance test results due to variability we introduce in the sampling and sample preparation process. Of course, we want to make sure that we use appropriate handling and storage. And I've probably beat this to death, but time and temperature is really, really important with hot mix. And then that list of things, having qualified technicians, the right tools, the right sampling and testing a PPE and equipment, all those things will make sure we get good samples and we minimize variability in the process. And with that, I think, Tim, this is where we open it up to more questions.
Yes, sir. I want to thank you for that information, Adam. That was great, man. We had a couple questions already. If you have a question, go ahead and type it up and we'll get it out there real quick. We have a few minutes left. We did get one comment based on the previous question. The previous question was about a procedure for warming mix to temperature and different things. And the comment was, along with specific and consistent reheat times and temperature, there are often larger tolerances used to be considered verified. Much like our proficiency samples are very specific on reheat temperatures and oven times, the more the absorption, the higher the tolerances. So I know we probably all dealt with that. So that's something I wanted to go ahead and throw out there. We had received that comment a little while ago. If you have a question, go ahead and type it in. I know I talked to Adam a little bit yesterday. One of the questions we had for him was what brought you to the realization that materials management was so important and to go through all these steps to make sure that it was done right?
So I worked, thank you, Timmy. I worked for a large producer for many years, and the realization for me was I got in the middle of trying to resolve disputes, but basically in the Western U.S. and whatever 6 or 8 states, 9 states maybe, whatever. There was between aggregate and hot plants there were, I don't know, over 200. And then ready mix plants thrown in there also. So there, that stuff came up, right? And so with the implementation of PWL specification, quality assurance specifications that relied on PWL, if you go back to the sort of early mid 2000s when that was going on, there were a lot of bumps in the road getting started. So it was really just dealing with those, trying to help get those issues resolved. That led me to paying attention to all this stuff. And I was actually, the company that I worked at went through a continuous improvement initiative also, and I went through the Six Sigma, the black belt training and all that good stuff, and that helped solidify some of the reasons why we were seeing some of the issues we were seeing also from a statistics perspective.
Okay, very good. We did have a question. Somebody wanted to know if you could repeat the 2 NCHRP report numbers for them.
Yeah, here, I'll just go back to that slide here, and it's NCHRP report 818. And then there's the other one is a NCHRP synthesis 552. And there are actually a whole series of NCHRP reports that revolve around quality assurance. If you go do a search, you'll find a whole bunch of them. And there's good nuggets in all of them.
Sure.
Yeah.
Okay. Let's see. Anything else? I know another question we kind of asked you yesterday was, let's say you had some material and you were expecting a certain result, and as things went along and results came out, they weren't what you were expecting. I mean, what does it take to get back to where we can actually discover that it was a material issue and not some other problem?
Okay, that's a great question. The term flyer, some of you are probably familiar with the term flyer. I think you're sort of describing what often gets called a flyer, Tim, right? And I've heard that used by both DOT folks or agency folks and producers. Right. A test result happens for a reason, right? And so what's really important is if you get something that's not expected, that rather than just saying, well, that's a flyer and throwing it away, or saying, well, let's just go grab another sample, you need to understand why that occurred. And if you don't, it can happen again. Right. So if you've ever looked at like a fishbone diagram for trying to take apart, so you take, let's say you've got mix that's produced. Well, you got binder going in, you got aggregate going in, you got a plant involved, you got sampling, you got got all those pieces going in. So you have to work back and look at each of those and say, well, hey, was our gradation okay on that that lot, or et cetera, et cetera. But it's really to just dismiss samples is really dangerous because they'll come back. They're gonna happen again. And so you're not really, you're addressing the symptom by saying, you know what, this is a flyer, I'm going to grab another sample and just use that, rather than addressing the root cause of the problem so that it doesn't happen again. I mean, sometimes, a sample gets dropped in the lab and that type of thing. I mean, you know what happened, you know what I mean? It's bad, you shouldn't use it. That's right. Different from thinking that all the proper procedures had been used and everything, and all of a sudden you get a number that jumps out, that's way different than you anticipate.
Yeah. Okay. Well, we're at the 3 o'clock hour, it looks like. So I'm going to ask Molly to take over. I want to thank Dr. Adam Ham for his time today and appreciate all he did to put this information out there for us. We appreciate it, man.
Yeah. Thank you for the opportunity to participate today.
Yeah, thank you, Tim, and thank you, Adam. And it's a new year. Everybody's making New Year's resolutions. So this was a great review to remind us to put those proper policies and procedures in place too, and implement those good habits. So thank you both again. And thank you all for tuning in from wherever you may be, and have a safe, happy, and healthy 2021. Our next road trip will take place in just a couple weeks, and we're going to review the national update on balanced mix design. So we hope you can join us then. Thanks again, guys. Have a great week.
Thank you.
Rest of your day.
Thanks,